Okay. Right, let's take this part two. That means the 10th turn, right? Here, the similar question again, right? They're asking about the density kind of question. Predict the density of antimony. I have done that, right? You said I actually came out of the story, but it's easy to mark like that. Right. Let's see. What's the answer? Predict the density of antimony. Antimony density can be in the middle of these two numbers, right? So it's kind of like 7. If you take 7 point something, that will be fine, I think. Okay. Value between 6 to 9.5. Yeah. So next one is suggests why it is difficult to predict the melting point of arsenic. Melting point doesn't have a trend. If you see here, the trend is not there, right? There's no good trend here. Minus 210, 44, then 631, then 272. So we can't predict this one, this number, right? There's no trend. You can say there's no clear trend. Next one, the structure of the two compounds are given. Sodium phosphide and this is phosphine. Now explain the terms of structure and bonding. Why compound R has a high melting point than S, right? So of course you can see S is a molecular substance. You can say covalent molecule. So it has a lower attraction, or you can say lower, less strong or less or weak attraction. Weaker attractive forces with the other molecules, its own molecules, right? Phosphine is covalent bond. But in sodium phosphide, it's an ionic compound, so it has stronger electrostatic attractions between the ions. So it is difficult to break. Let's see what that is. Yeah, R is an ionic structure. Oh, ionic lattice, whatever. Right? R bonds are strong. Yeah, you have to say through the lattice, right? Because ionic bonds. S is a simple molecular structure. Okay, or simple molecule, or simple covalent, that's fine. Then S weak bonds. Yeah, S has weak forces between molecules. And the attractions or the molecular forces are weak, right? The next one, explain why compound R conducts electricity when molten. R is an ionic substance. No? Ionic substances can have what? Right. Ionic compounds, or ions can freely move when it is molten. Ions can freely move, carrying current, right? Ions can move. Okay. Next one, dot cross diagram of the molecule compound S. Now, S was phosphine now, right? Let's see how you draw S phosphine here. They must have given, I think, no, they just given 3 pairs of bonding electrons between H and P and 2 non-bonding electrons on P they wanted, right? If you draw it and see here, right? Phosphine. I can't draw circles nicely here. This is not easy to draw with the, I mean, so wow, what's that? That went really close. Okay, so phosphorus and hydrogen, right? Hydrogen, hydrogen, and hydrogen. What are the bonds electrons you need, children? You check your answers, right? Here I'm going to take the spotlight, I think that's better. Highlighter, right? So we can have one electron here, one electron here, one electron here from phosphorus, and the other 2 electrons should be remaining in the phosphorus shell, right? Phosphorus has 5 electrons in the outer shell, and then hydrogen each gives 1 electron, right? The story. And 3 bonding electrons. That means 3 bonding electrons and 2 lone pairs. Sorry, 1 lone pair. That means 2 electrons on the phosphorus remaining in the outside, right? Don't forget this one. Huh? You'll forget this point. Sometimes you can put extras also. That's the thing. So next one is oxide is this one. Calculate the percentage of by mass of phosphorus in this compound. Now, we used to do these questions. They were not there in this paper. So yeah, calculate the percentage by mass of phosphorus. Huh? How do you find that? Phosphorus pentoxide total mass you have to calculate. P4O10 total mass you can take, and phosphorus on top of that. Take the mass of this one, and they have just given the answer. They only gave answers, but we can take the molar mass of phosphorus here is 284. So molar mass of phosphorus pentoxide is 244, sorry, 284. Then there should be 4 times 31. 4 times 31 is 124, right? 4 times 31. Am I correct? 124 divided by 284. It's the number of yeah, and the percentage. It should be multiplied by 100 also, okay? So you get now answer here that should be multiplied by 100. That's going to be, I think, 40 something. Why is it? Because the mass, like the molar mass is 284 for phosphorus oxide, this one, right? And the phosphorus, there are 4 atoms. One phosphorus atom is 31. 31 times 4 is, I think, 124, right? 124 divided by 284 multiplied by 100. So you get 43.7. I think that's the calculation. That's it. And then that's all. Yeah, that's all. And then we are going to finish, okay? All right. Okay. Stop recording.